What's going on, everyone? Welcome back to another episode of the Muscle Memoirs podcast. Today, we have an outstanding episode for you. It is my pleasure to introduce Dr. Grant Tinsley. Grant, how are you doing today?
I'm doing well. How about yourself?
I'm doing fantastic. Before we get into the weeds here, could you give the listeners a little bit of background about yourself and your current research focus?
Yes. So I'm currently an assistant professor at Texas Tech University. Those we were just talking about offline. I just got tenure and promotion. So in September, I'll be an associate professor, which is pretty exciting. I direct the energy balance and body composition laboratory here in our department. So in my lab, I have a team of about 11 students, kind of spanning undergraduate, master's, and doctoral levels. And we conduct research in three main areas. One, which is the one we'll be chatting about today, is looking at dietary interventions and in particular intermittent fasting in active populations. We also have an interest in looking at the validity and reliability of different body composition estimation techniques. And then kind of our third prong is sort of a general sports nutrition focus. And we've conducted several dietary supplementation studies to that end. So yeah, I mostly conduct research here. I'll teach one or two classes a semester in sports nutrition, skeletal muscle physiology, and similar topics. So yeah, that's kind of the rundown on my end.
Excellent. As you mentioned there, we're going to be diving into the topic of intermittent fasting today and really teasing out the details here of whether intermittent fasting has uniquely beneficial effects on health, body composition, and performance. And before we do that, I want to quickly set the stage to make sure that everyone is on the same page here in terms of terms. And I will try to go over this briefly, and then I'll give you a moment to correct anything I get wrong or add in nuances that will be relevant for our discussion. So, when we look at intermittent fasting, this is a umbrella term, right? So we're looking at more or less three distinct areas when we're talking about intermittent fasting. We have alternate day fasting, which is going to cycle back and forth between ad libitum consumption with days of no energy intake or modified fasting days, which we can generally refer to as somewhere around 500 calories from what I've seen in the literature. And then we have periodic fasting, which might encompass anywhere from 2 days per week of complete fasting or modified fasting to anywhere from maybe one fasting day per month. And most listeners might be familiar here with the 5-2 diet. That seems to be the most popular, which would fit in here. And then lastly, and probably the most popular, something we'll be expanding on the most in our discussion today is time restricted eating. And that would be eating instead of feeding in the context of humans, right? And for this, we're looking at a limited window each day of eating. So you're going to be consuming all of your calories somewhere in the range of probably 4 to 12 hours, depending on whatever window that individual selects. And it seems the most popular iteration of this is 16/8, which is an 8-hour feeding window with a 16-hour fasting window. Do I have that right, Grant?
Yeah, that was a great summary.
Nothing to add there before we get going?
Not really. No, I think that was a great summary.
All right, let's do this then. So you recently gave a fantastic talk for the ISSN, a webinar recently, and within that, I made sure to note that you prefer to talk about IF in the general population before athletes. So we are going to start there. And personally, I might be more interested in the research on IF for the general population specifically. So that's fine with me to start the conversation from here. Very generally, before we get into the nitty gritty details, when we look at the research on intermittent fasting strategies in the general population, does it seem like there are any uniquely beneficial effects on health that are independent of just pure caloric restriction?
Yeah, so there is some evidence. It's relatively limited, and I'll talk about a couple of those lines of evidence. But from the big picture, our long-term studies don't show clear benefits for the major outcomes we look at with body weight, body composition, and health markers. There's a couple exceptions, but most long-term studies would essentially present intermittent fasting in general, and I would say time restricted eating in particular as well, as a viable but not inherently superior option for weight loss and health improvement. So that's kind of this standard answer. That's overall in totality what I would say if I had to give like a one sentence, like, what do you think of intermittent fasting? I'd be like, it's a viable option, but not inherently superior. With that said, what you just asked is one of the major research questions. So quite a few studies have established different forms of intermittent fasting as a viable option. But this question is, particularly in some of these studies where participants are, say, free to select their energy intake level. With time restricted eating, this comes up a lot, that there are studies where the feeding window or eating window is truncated and these participants aren't necessarily prescribed an energy deficit, but because their eating window is shortened, they will end up eating in an energy deficit. So then, of course, and for good reason, people say like, oh, well, all these health improvements are just because they're in an energy deficit and lost weight and so on. So researchers and I think practitioners or well-informed practitioners recognize that this is still an outstanding question. So there are at least 3 human studies that have shown unique benefits of intermittent fasting independent of weight loss, or even changes of weight at all in some cases. I would say, and I can talk about those a little bit, but I'd say as a big picture takeaway, the benefits are not consistent enough or of a large enough magnitude to be at the point where we say, oh, everyone needs to be fasting for health. So it's definitely interesting, kind of raises the eyebrows, lets us know more research needs to be conducted here, but it would not be at the point where I think like all dietary guidelines should include the fact that people should be fasting or anything like that. With that said, that some of the benefits that have been shown independent of weight changes largely relate to glucose handling, glucose responses. So there have been some benefits for insulin sensitivity, glucose and insulin concentrations, again, independent of weight changes. This has been done a few different ways. In some studies, it was with matched weight losses between, say, a time restricted eating condition and a non time restricted eating condition. In another study, one of the studies was like a year-long alternate day fasting trial where they saw improvements in insulin sensitivity, reductions in insulin concentrations in the alternate day fasting group as compared to just a separate parallel arm. Most of the studies, I think 2 of the 3 that I'm thinking of off the top of my head are early time restricted eating studies. So I'm guessing we will get into this later, but there's kind of an added layer of complexity here because this is a time restricted eating program where the eating window is essentially from the morning, normal breakfast time, until the earlier mid afternoon. And traditionally, most of the time restricted eating studies, say with a common 8-hour window, like you mentioned, would be from around lunchtime to the middle of the evening. And that's something that's generally pretty socially acceptable. There are quite a few people who don't have a problem skipping breakfast. There are quite a few people who want to eat dinner with friends or family, something like that. This early time restricted eating is a little bit more dramatic, even with the same duration of eating window, because you might be eating your last calorie intake or consuming your last calorie intake at 2 or 3 p.m. So the reason I mention that is, a couple of these studies that have shown benefits of time restricted eating independent of weight changes were with this early time restricted eating variant. So we don't know for sure if that would apply to time restricted eating performed with kind of the more standard lunch to mid evening window.
Yeah, early time restricted eating is definitely something I want to expand upon. Based on your comments there, I think this is an excellent time to segue into it here. So, why would we see benefits from this implementation of time restricted eating specifically? What advantage is there to pushing calorie consumption to earlier in the day?
Yeah. So the big picture answer would be that we have quite a bit of evidence supporting the fact that earlier in the day, your body handles ingested nutrients a little more effectively than later in the day. And that's based on postprandial, so post eating responses, largely in glucose and in blood lipids. So, quite a few studies have established this. If you feed an identical meal, say in the morning versus nighttime, that the body does not process it identically. So and that it processes it better earlier in the day. So from the big picture perspective, that's kind of the underlying rationale. So better alignment with circadian rhythms. And I'd mentioned that this isn't, like, again, early time restricted eating is a little bit of a dramatic protocol. I think the overall eating window isn't extreme, but the thought of not eating past 2 p.m. I personally don't love, probably lots of people don't love. So there are other ways you could still apply that underlying message of, your body may process nutrients better earlier in the day, or say during the daytime generically. And that could be something simple, even without shifting an eating window, but saying, okay, looking at my calorie distribution over the day, I have a small breakfast, small lunch, large dinner, large after dinner snack. You could do something where you didn't change the eating window at all, but change the distribution of calories within your eating window. And there have been studies done that are really similar to that, where there's essentially a very large breakfast and small dinner condition, or a small breakfast and large dinner condition. And eating a larger proportion of those calories earlier in the day was helpful actually for body weight and body composition changes over time, as well as health markers. So that, not to get us off track, but just to mention that you can sort of address that, or try to, target, if you want to call it that, some of those circadian potential benefits without, you know, forbidding yourself to eat after 2 p.m.
Yeah, I love that practical application there. Recently, I had on Dr. Nicola Guess, and we were talking about a few different dietary interventions to manage type 2 diabetes. And she was like, I use a wide variety of approaches. I've had numerous clients implement a ketogenic diet successfully and adhered to it for years on end. And she said, I have never, ever had a client successfully stick to early time restricted feeding.
Mm. That's super interesting. Yeah.
Yeah, which I think speaks volumes from the practical application of this approach, and probably shifting those calories to earlier in the day makes a lot more sense for most people. What comes to mind is those Jakubowicz trials, right, from
Yeah.
around the 2013, 2014. Yeah, so great stuff there. Now, more or less we kind of went in reverse of how most would consider the science and the evidence behind a concept, right? So we started talking about some of the interventions on intermittent fasting strategies and the outcomes, whereas if we were looking at this from a scientific perspective, we might start with the mechanisms, right? So like on paper, why would this work, and then seeing, okay, does it actually pan out in humans? But considering this is a very early area of research and we still have so much more to learn, even though the interventions as of now don't really point to there being a unique effect, I think it is worthwhile to discuss, at least mechanistically, what might be going on which would allude to there potentially being a benefit. So something that gets tossed around a lot in this space, right, is the concept of autophagy. I don't even know if I'm pronouncing that correctly. So
Yeah. Yeah.
is that okay?
That's how I
So
pronounce it. So either we're both wrong or we're both right.
excellent. So people like to toss around the term autophagy, and they might point to these other things that we're seeing in terms of changes in fuel utilization, the predominant substrate that's being used for energy. So could you expand on those for the listeners? So what is autophagy, and why would it matter? And then maybe some of these substrate changes that might or might not suggest there may be some sort of benefit here.
Yeah. So autophagy, there are multiple types of autophagy, but broadly, this is a cellular housekeeping process. So it's a process by which the cell breaks down components that are either dysfunctional or that it no longer needs, and can essentially recycle the building blocks of those components it's breaking down. So big picture, you can have, without like going into too much on the cellular level, but you can have what's called an autophagosome. So a sort of vesicle within the cell that's sort of built around objects within the cell that the cell wants to degrade, that will fuse with something called a lysosome, which has enzymes that will break down these cellular components. And then kind of the little pieces, the building blocks, the Lego bricks that are left can be used for something else. So it is essential. It is an essential process. There's good data that impairments of autophagy are related to a number of disease states and adverse health effects. Now, in terms of fasting, so this would hold true both for autophagy and for the substrate utilization. There are a few disconnects at different levels. A major one is the duration of fasting needed for a particular metabolic event to happen, and how that's often much longer than the fasts people use with common intermittent fasting protocols. So this isn't exclusively true, and I'll mention why in a minute, but largely lots of the metabolic changes we see with fasting start to happen and really ramp up towards as you're getting closer to 24 hours. So maybe in the 18 to 24 hours of fasting and beyond. And like we just mentioned, if we're taking time restricted eating as an example, the most common implementation might only have 16-hour fasting windows each day. So based on several studies, we people who follow those protocols may be stopping just short of a variety of metabolic events occurring. Um, so that's kind of a aside. There is a little bit of evidence showing that in the early stages, relatively early stages of fasting, there might be an increase in some components related to autophagy. So the shortest term one I've seen was that there was an increase in some proteins involved in autophagy from 8 to 13 hours of fasting. So after an 8-hour overnight fast, extending it to 13, they were seeing upregulation of several proteins involved in autophagy. So that's the shortest term one I've seen. That doesn't tell you anything necessarily about the long-term effects. The magnitude also wasn't entirely clear if it was relevant or not. But that's at least to say that, even though there are lots of outlandish claims made, it's not completely untrue to say that this process could be getting affected during the shorter term fasts. With that said, again, the major changes are really occurring later. So some of these are tied to the point at which liver glycogen is depleted. So liver glycogen will be almost completely depleted by about 24 hours of fasting. I think it's been estimated there's about 10 or 15% of liver glycogen content left at that point. This is also probably when you start to see ketone bodies starting to rise. There are a few studies that are very nice, but kind of miss the time points you really want to see. But there's good evidence that after an overnight fast, there's relatively low concentration, say, of beta hydroxybutyrate, one of the major ketone bodies, but by 36 hours of fasting, that's increased substantially. So some studies like that, which are very informative, are just kind of missing a couple time points we'd like to see at maybe 18 hours and 24 hours of fasting. But it's fairly consistently seen that, and as a broad principle, as someone continues to fast, say from overnight fast, and you continue to fast, you're seeing this shift in substrate utilization from being carbohydrate dominant to lipid dominant. And this isn't, magical. This is just physiology. So you have elevations in free fatty acids. Again, at probably closer to 24 hours of fasting and extending on into 36 hours and beyond, you're starting to see the increase in ketone bodies kind of as an effect of that increased lipid metabolism. And those, ketone bodies can be metabolized as well. But again, big picture, you're seeing decreases in glucose, decreases in insulin, decreases in carbohydrate utilization, somewhat related to depletion of liver glycogen, and then increases in free fatty acid, energy derived from lipid, ketone bodies, et cetera. So that, just to tie it back to the original concept, lots of these changes are well documented. But again, many intermittent fasting programs, the duration of the individual fast may not be long enough for these to really be occurring. But those occurrences are kind of where some of the physiological mechanisms people like to tie into intermittent fasting programs come from.
Excellent. Coinciding with this fascination with not eating nowadays is this rebellion against breakfast specifically, right? So most people, as you mentioned, when they utilize time restricted eating, they're probably going to be skipping breakfast and maybe starting around that usual lunchtime. That will be their first meal of the day, or that's breakfast breaking the fast, right? But as you mentioned, based on what we know in regard to circadian biology and some of the other research on the topic, we do seem to process nutrients more effectively earlier in the day. Now, when people look at breakfast specifically, they basically want to brush aside all of this epidemiological evidence, right? And, the government's been lying to us all this time. You can achieve your body composition and health goals by skipping breakfast. Don't let them tell you it's the most important meal of the day. You were part of a review paper fairly recently looking at breakfast skipping and cardiovascular outcomes. So, could you touch on what you found in this review, and then perhaps provide your thoughts on this typical notion to just brush aside any epidemiological evidence on breakfast and just the general importance of eating a meal, within some relative time to waking within a couple of hours rather than skipping it.
Yeah, so my views on this are sort of middle of the road, and I think that's more or less what we came to in the review article. Also, I think people can err on both ends. So breakfast skippers, as you mentioned, can easily discount a lot of epidemiological evidence, which there are some legitimate reasons for that. The more controlled trials of breakfast versus not breakfast, I think do support the idea that breakfast isn't the most important meal of the day. With that said, there are lots of components to this. So one, everyone, if you eat in a day, you are breaking your fast sometime. You're eating your breakfast sometime. There's the component of, two people could eat at 10 a.m. One of them got up at 5 a.m. One of them got up at 9 a.m. So it's like for one of them, they're eating within an hour when they wake up. For another, it's 5 hours later. So that's just kind of an aside and kind of semantics on breakfast and all that. I think it would be unwise to completely dismiss the epidemiological data, especially when it's supported by some of the studies we talked about, looking at, say, nutrient processing of a meal earlier in the day versus later in the day. The reason why I would still generally agree with the statement that breakfast isn't inherently the most important meal of the day is because, sort of like we were talking about briefly earlier, things that may be beneficial from a circadian biology perspective could still be applied without breakfast. So say someone got up at a normal time, skip breakfast. Now if they're eating a tiny lunch, like tiny, whatever, and then eating all their calories largely at like dinner and later, that's not ideal in terms of a like circadian biology perspective. But someone could, if say for their lifestyle, for whatever reason, skip breakfast, eat a large meal and kind of taper their caloric intake over the rest of the day. And they may end up still with a 8 or 10 hour eating period, but they've weighted the distribution of calories in a way that would be a little bit better. So again, I think the controlled, like the RCTs on randomized controlled trials on breakfast consumption, don't overwhelmingly support its necessity. But I mean, it is consistent with beneficial circadian alignment, essentially. So again, that's kind of why I'm middle of the road, and it's hard for me to separate the application from the science, because like in the scientific perspective, if they're omitting a few hundred calorie meal versus that presence, that doesn't consistently lead to like major body weight, body mass, anything. Sorry, body weight is body mass, and body composition changes over time. On more of like the metabolic outcomes, sort of similarly, I think there's a lot of context needed there. So I think as a dichotomist, like skipping versus not skipping, it's not, that's the way people view it, but it's not always the most productive way to view it, because it's hard to give a like sort of yes or no answer to the question breakfast question mark.
Absolutely. Per usual, it depends is more or less what you're going to get when you're really seeking the truth for the answer. It's going to be context dependent. There's a whole lot of gray we need to work through, and the truth is most likely never going to be in either black or white. Now, within under the guise of intermittent fasting, almost by extension of not having as much time to eat, there's going to be a reduced meal frequency. And within this context of, most people like to think, well, more or taking it to the extreme end of things must be better. More is better, bigger is better. So I want to discuss something that seems to be becoming more popular from what I've observed, and that is OMAD, or consuming one meal per day. I don't think there's too much research in regards to this topic, but what have you seen, Grant, in terms of cardiometabolic factors and certain changes from gorging with on one meal per day? Does there seem to be any deleterious effects from this sort of approach?
Yeah, so I'll answer that. I'll preface it with saying the meal frequency thing is a little bit interesting. Some trials and some of the ones we've been involved in have sought to, or have equated meal frequency. So there are some trials where, say, even with a 12-hour versus 8-hour feeding window, it's like 3 meals and a snack very spread out, or 3 meals and a snack fairly condensed. I was a little surprised in one of our studies with 8-hour time restricted eating, as compared to a control group that ended up eating over 12 to 13 hours a day. The meal frequency only differed by one eating occasion per day. So in the TRE groups, and we did have them consume a protein supplement daily, so that could account for one of these. But they had 4 eating occasions in that 8-hour period, and I think it ended up being about a 7.5-hour period, as compared to 5 eating occasions in the control group that was more spread out. So especially if you're not, and I'll talk about the more aggressive like OMAD style in a minute, but if you're doing kind of a moderate approach, like fairly conservative approach, like the 8-hour, you can get in a meal frequency that actually agrees with most kind of traditional recommendations for active individuals, which is kind of interesting. But as you're talking about the more extreme variances, you get shorter. Say you cut down to a 4 hour window. I mean, even if you ate a big meal on each end and a big meal in the middle, it'd be like, pushing it, and you might be a little uncomfortably full if you're trying to get in a lot of calories with getting those 3 meals in that 4 hour period. So OMAD, there are technically some studies that have been done that are comparing, say, 1 meal a day to 3 meals a day. But if you look at them, and the major one I'm thinking of, there were a couple publications out of it, one by Stoat, one by Carlson, back around 2007. But the feeding period was something like 4 hours. So it was kind of 1 meal, but it was kind of like, here, you have access to food for 4 hours. And they were actually supposed to eat their full daily caloric intake in that period of time. So it's challenging to apply this to OMAD because it's interesting. One of the discussions in these papers said essentially participants were uncomfortably full. They're pretty much being force fed, and they were trying to get them to get up to the calorie intake, and they couldn't quite do it. There was just a very slight calorie difference between the 3 meals a day and 1 meal a day condition. And this was in highly controlled settings. So that actually, to me, that's one of the most interesting parts of those studies, is that that's some decent evidence that this would, and it's common sense also, that this would be effective in promoting an energy deficit. If it's like incredibly difficult to eat that amount, say their total calorie intake in a 4 hour period, that means by extension, if they were doing this in the free living setting, they would have stopped before they were just like forcing themselves to be incredibly uncomfortable. So in that sense, from a purely calorie deficit standpoint, if you eat 1 meal a day, you'd have to eat a very energy dense meal, I think, to eat to like match or exceed your daily energy requirements. And it could certainly be done. And we can talk about this in a minute. We've done some acute fasting studies where we monitor what people eat in the evening after 24-hour fast. And some can actually over 100% of their weight maintenance calories in a short period of time. So there's definitely a level of individual variability in how much someone compensates for this period of fasting. But say someone eats, a large meal, but is still getting energy deficit. Some of my concerns on an OMAD approach, one would be like the nutrient density, like how could you get the calories you need and the nutrients you need, extending beyond just macros to micros and other things. Can you get that in 1 meal? You might be able to if you're eating very nutrient dense foods, though. These will often be relatively satiating. If you're trying to hit your protein goal, if you're trying to get up even to say a lower end, you're like at 1.2, 1.4 grams per kilogram in that period of time, there'll probably be some discomfort involved. It's very possible you'll be craving things that aren't, you might not want to get all your servings of fruits and vegetables. You might want to dive into a pizza or a steak, something. Not that there's anything wrong with those per se. So there's not a lot of research on it. So again, I guess to summarize my point, I would say I think it could be appropriate for a select group of people. I think it would make it more challenging to hit nutrient intake goals, looking beyond just macronutrients, though, including macronutrients as well. So I'd say maybe select applications, but I would agree with your statement. Well, I don't know if you made the statement, but the statement I perceived you making of more isn't always better, or more aggressive isn't always better.
Something you touched on there that I want to address before we move on to athletes, and that is compensating for a complete fast or a modified fast. So when it comes to a day of no energy intake or only 500 calories, based on the research, how does it seem like the average individual does the next day with their eating? So when they eat ad libitum, are they making up for that deficit they created and just overeating, or does it seem like they just aren't able to make that happen, and we just end up with a energy deficit over the course of the week?
Yeah, no, that's a great question, and that has been looked at with varying durations of fasting. So it's been looked at with about like more or less 20 to 48 hours of fasting. We did a study related to this, which I'll talk about, with a 24-hour fast in our lab. So there are a few components here. One, if someone fasted for a whole calendar day, say like they would in true alternate day fasting, that would result in about a 36-hour period of fasting. So sometimes people think like one day of fasting, 24 hours, but 24 hours is more commonly something like dinner one night to dinner the next night, where you're not actually having a calendar day where you're not eating. So I'll start with the one from our lab. That's essentially what we did. We had people fast from dinner one night. We, told them to stop eating a particular time. They reported to our lab first thing in the morning, stayed in our laboratory all day till they hit the 24 hours of fasting. And we were doing a variety of metabolic measurements. and then and subjectives like hunger and all that. And then we allowed them to eat whatever they wanted, but had them record everything essentially for that single period of time in the evening, a couple hours that they had to eat. And it was amazing how much the compensation varied. So on average, in the evening, people ate about 60% of their weight maintenance calorie needs, which we estimated by metabolism testing in the lab. So on average, 60%. So they still had a pretty decent deficit, but it was a relatively rigorous thing they had to go through, a 24-hour fast. The range though was crazy. So it ranged from about 7% of calorie needs. So there's some people that went and just essentially ate like a moderate sized snack, and they asking them about this, like, yeah, I just wasn't actually hungry. Like I was hungry at certain points, but my hunger subsided by the end of the fast, and I didn't feel like eating that much, so I had a snack and went to bed. There were others who ate up to 110% of their weight maintenance calorie needs, who went out to eat, chose some very energy dense foods, and ultimately completely negated the calorie deficit they had produced from the fast. So we actually in this study did multiple 24-hour fasts. We did 2 different 24-hour fasts, and we did the same thing each time. And we also saw a lot of within individual variability. So not to, from one complete extreme to the other, but there were certainly times where people approached eating all their weight maintenance calorie needs where they were compensating, they were, eating a very high calorie meal, and other times where they didn't. So there's some between individual variability and within individual variability. One thing we recommend in that paper, kind of as a discussion point, is this idea of test fasting. So if someone is pushing into a protocol that's a little more aggressive before committing to it and saying, okay, I'm going to do 4-hour time restricted eating indefinitely, but would be to do a few test fasts and pay a lot of attention to their hunger cues, their food choices, of course, subjective feelings and all that, and see, even though you can, kind of habituate to some of those items, just see like from the outset, am I getting some indications that this is going to be problematic to me, or might even promote like, binge eating tendencies, something like that? Or is this something that I can handle and still eat, with some level of moderation after the fast? So that was kind of in our study. Broadly looking at all the studies, the big picture finding is after a period of either a very modified or complete fasting, generally people will consume more calories at the first unrestricted food access. And this has been looked at in a lot of interesting ways, including giving people a standardized meal after the fast and not having the unrestricted access be at the first meal, but be at a later meal. But it seems like the first time they do have unrestricted access, individuals will consume more than they normally would. But in general, it is not enough to make up for the calorie deficit. So at the group level, it's not enough to make up for the calorie deficit. Again, with a caveat that there are some individuals who essentially do make up for the full deficit.
The results from your trial are particularly fascinating. It has the gears turning for me. Do you have a hypothesis as to why an individual might only have a small snack the next day? For me, what immediately comes to mind is we have this research showing these appetite suppressing effects of ketosis, and I would assume that that's a long enough fasting period for ketones to be elevated. I mean, could there be individual differences in the appetite suppressing effects of ketosis, or what do you think? What's going on there?
Yeah, that is one that I wondered about as well. So for this study, we actually had them on a standardized diet we had provided to them for 3 days prior. So if it weren't for that, I would think that, say, variation in their macronutrient composition the day before, like say they didn't have an appreciable amount of carbohydrates within the last meal or two before the fast, they might have been able to enter ketosis more quickly. And by the end of the fast, maybe be at a point in ketosis, a little further than we would normally expect at 24 hours because of the diet they had prior to the fast. So yeah, I'd say there's probably there is variability in how quickly someone would enter ketosis and in how much of an appetite suppressant effect they would get. Um, it's interesting on the subjective hunger. It did sort of ebb and flow throughout the day. So some of it could be a timing. It's like it happened to be at a relatively low point. They were tired from having to, I don't know, just sit around our lab all day chatting with us. And, they ate and went to bed. Maybe it's the type of people that went to bed earlier. They're like, it's almost bedtime. I'm just not, not going to deal with whatever, preparing a meal. So I think there are a variety of like behavioral and physiological implications there. But my guess would be the people on that very low end, and we did this with 2 fasts, but if we did this with a bunch of fasts, I'm sure that was probably for that individual, I'm guessing a little bit of an outlier on the low end. It'd be surprising after, habitually fasting for 24 hours at a time if they would just have a small snack, but I could be wrong.
Hey guys, Mike here. If you're interested in learning more about how to maximize your health, body composition, and performance, head over to hammerawayfitness.com where you can sign up for coaching or even just schedule an hour consult with me to get some of your training and nutrition questions answered. Also, if you enjoyed this episode as much as I did and would like to further support the growth of the Muscle Memoirs podcast, you can give a donation to the link in the show notes, leave us a review, and or share this episode with your friends, whether that be dropping the link in a group chat or putting a screenshot in your Instagram story. I truly appreciate it. Very interesting. Okay, let's move into athletes, and I think we can kind of split up this section into real athletes, so to speak. So we'll be talking about the role of fasting for endurance training or training for mixed sports like soccer, and then we'll get into resistance training as well. But I think a good place to start would be on endurance exercise because there's a few different little subcategories to tackle within this. So, generally, for the listeners here, how does fasted training seem to affect endurance performance?
Yeah, so there was a really good meta-analysis on this in 2018 by Aird, AIRD, and colleagues, and they did a really nice job, and I thought presented a really balanced view of everything. So for prolonged duration exercise, and I believe they defined that as about 60 minutes or longer, fasted training can lead to an impairment, or did lead to an impairment. It wasn't a enormous magnitude of effect, but certainly something where you wouldn't advocate fasting before you needed peak endurance performance. So they saw that in shorter durations, say under an hour, the effects were less clear. There wasn't a definitive detrimental effect, though I would still say, it's something that would be generally in the endurance category, but under an hour, I still wouldn't recommend. I don't think, hopefully, anyone would probably recommend fasting as an acute performance enhancing strategy where you would actually perform better that day because of it. Except maybe the odd person who, well, not odd person, but occasional person where um, they're just like very sensitive to GI contents and they are not willing to get up early enough to eat and let it fully settle before an event. That's the main situation I could see in as a tangent. In those situations, you could target like pre-bed nutrition or something where it's not like they've been in a long fasted state by the time they wake up in the morning. So generally, longer duration endurance performance impaired by fasted training. The interesting thing and why I think they present a nice balanced perspective is they talk about some of the evidence for potential benefits of incorporating fasted training. Again, not for acute performance, but in terms of signaling for adaptations that would be relevant to endurance training. So largely related to mitochondrial adaptations, adaptations in mitochondrial proteins. And that was related to increased free fatty acids in the blood during fasted exercise and their role in signaling. So they presented an interesting view where there could be a theoretical benefit, metabolic benefit of fasted training, say for select sessions, again, with the major caveat that this is not, I'll say it a bunch of times, so there's no confusion. This is not an acute like performance enhancing strategy.
Excellent. I do appreciate you touching on these concepts of train load there. And maybe, as a long term investment, maybe there's some benefits, but in the short term, if you want to maximize your endurance performance, eat some carbs. Now, sticking to the topic of endurance performance, there was a recent trial by Metcalf which looked at cycling, I believe, and this kind of made the rounds within the evidence-based fitness industry, particularly when it comes to bodybuilding, physique sports, powerlifting, and that was because the this trial showed that when you skip breakfast, despite consuming the same amount of calories in one meal, right? So for example here, I forget the specific intervention utilized, but if we have 1,000 calories, one group consumed 500 at breakfast and one consumed 500 at lunch, and the other one just consumed 1,000 at lunch. So these are calorie equated, but the meal frequency is different. In this study, it seemed like they found that performance was compromised when they skipped out on breakfast despite equating calories. And this was really interesting. And I want to get your take on it, Grant. So, what do you think is going on here? Is this just a unique trial, or are there mechanistic reasons that might suggest that meal frequency does matter to a degree when it comes to optimizing training performance?
Yeah, I agree. It was a very interesting trial, and I don't think the authors present it differently in this, but it was a small trial. It is should be viewed as relatively preliminary, but definitely interesting and practically relevant to people performing endurance exercise sessions in the evening. Um, so one that I know you're aware of because you sent some information about this offline, but yeah, is the idea of a second meal effect, or the fact that having a first meal, and particularly a carbohydrate containing meal, may essentially set up the body to handle a second meal better, or more beneficially, largely related to, or what I've seen on this would be related to suppression of free fatty acids by the first meal, elevation of glucose, and that could sort of improve the ability to synthesize glycogen from the carbohydrate in the second meal. So that's very possible. There's a physiological explanation like that. I believe the authors also talk about more sort of like behavioral or psychological aspects. In fact, I think they might go as far as in the discussion at one point mentioning that they think it's possible it's more likely a psychological aspect, which was pretty interesting. With my lab's interest in resistance training individuals, I would certainly be interested. In fact, it's hopefully on our timeline for sometime in the next couple of years to replicate something similar with resistance training, and the type of resistance training where if there was an effect, you might be more likely to see it. So something high volume, more of sort of like a traditional bodybuilding style resistance exercise session rather than say like a powerlifting style session. So I'd be interested in seeing it there. The authors did a great job of presenting their individual level data. So you can look at, like I think is on the time trial performance. It was the majority of the small samples saw better performance with the spread calorie intake between breakfast and lunch. I think there were 3 individuals who had a better performance with all the food in a single meal at lunch. So it's a little hard to say with small studies like this. It's always possible that it is of course possible it's a real finding. It's possible that as a artifact of being not an artifact, but as a consequence of a small study, that they saw something that may or may not be replicated. And again, with my interest, it's kind of like, oh, that's interesting with endurance athletes, but really curious on the resistance training side, because that would have a lot of applications to some of the intermittent fasting work we've done, which has the exercise sessions in the feeding window in the late afternoon or evening. It's essentially really similar to that because these individuals might have eaten more calorie intake midday than they would if they were eating breakfast and lunch. So yeah, for that reason, I'm definitely interested in doing something relatively controlled like that, but in the context of a high volume resistance training session.
Now that you mentioned the discussion section, I specifically remember that as well. They were attributing the outcomes more so to psychological, which I don't know. I found like slightly puzzling. That
Yeah.
wouldn't have been my first inclination. We have these other studies on resistance training, right? I think there's like about 3 at this point, and they're all fairly recent, looking at skipping breakfast on resistance training performance. And in the one, there wasn't a placebo, and they were regular breakfast consumers, and they saw this downward trend in performance from skipping breakfast, and that seemed to be psychological because then we also had this follow-up in regular breakfast consumers, and when these subjects consumed like this viscous gel that they thought was packed with energy, there was no detriment in performance. So that kind of like solidified the case. And I think there was another one, but I don't really remember. Maybe you could fill in the gap there for me.
Those the 2 you mentioned. So off the top of my head, can't fill in the gap in detail, but yeah, the ones you mentioned, I think, are the ones that come to mind to me also. And that component that you mentioned of habitual breakfast consumers is also interesting because of the psychological aspect, and even going back to the Metcalf study you were just discussing, the perception of I normally consume breakfast, or perception of breakfast is good, breakfast is the most important meal of the day. These things, it's probably a little hard to divorce that. So it'd be interesting on another thing we've talked about in the lab, conducting at some point would be with resistance training and having kind of 2 groups, a habitual breakfast consumer, habitual breakfast skipper, and then each with and without breakfast to really tease out, like, for all we know, doing what's different than you normally do is detrimental. So for the breakfast skippers consuming breakfast, maybe they feel uncomfortably full. They're not used to doing that. Something in that vein. Um, so yeah, we have an interest in kind of teasing that out because to me, it makes sense that if someone habitually consumes breakfast and skips breakfast and comes into the lab and does a performance assessment, that their performance might be impaired. But there are also other groups that weren't explicitly examined in those studies.
In this theoretical study, Grant, what would be your hypothesis? So, if we use something similar to Metcalf, but did it in resistance training subjects, do you think there would be a detriment in performance if calories were equated? I feel like I would lean towards no, since, well, I guess depending on the training protocol, right? How voluminous it was, but considering the differences in the utilization of glycogen between something like long endurance based cycling compared to resistance training, I wouldn't imagine there to be much of an effect. But what do you think? What would be your hypothesis?
That's also what I'd hypothesize. So I'd hypothesize that if it was, similar to the Metcalf study, it was spaced far enough before exercise for this to digest essentially, even at the larger meal size consumed by the group that's consuming all their calories at lunch. I wouldn't expect a difference on the psychological side. I don't. Yeah, again, my opinion would be that for I'm thinking about all the resistance trained individuals I know, all our former participants, all these people. I think that largely based on what we've seen with like the training intensity and performance adaptations in our intermittent fasting studies that sort of have in a little bit of a less controlled way, but sort of have a chronic implementation of something like the acute study we're talking about, not seeing any detriments there. And just my own assessment that training intensity can be maintained. I would hypothesize there wouldn't be a difference. If there was, that would be very interesting. And again, this is another study, even within the context of that design, where breakfast skippers versus consumers might be relevant because if someone normally consumes breakfast and they have to skip it, even if they make up for all the calories and carbohydrates and so on, it could be in their head that they're like, I feel different than I do on a normal day, or it could be in their head that like, no, I always consume breakfast and that jump starts me for the day, or whatever it would be. So, but no, I'm with you. I would hypothesize no difference.
Let's get into the resistance training studies that you have conducted. I believe there was a recent meta analysis on this, and it was basically just like a review of all of your studies since you kind of have a monopoly in this area. So, when we consider the physique athlete and the application of time restricted eating specifically, do you foresee there being any benefits or consequences of this approach for either side of the coin? So when we look at the off season and trying to maximize increases in skeletal muscle mass, and when we look at, say, a diet or contest prep and retaining that muscle, do you think there are any mechanistic concerns when it comes to time restricted eating and being able to maximize either side of the spectrum? Or is it really just practical consideration? So like if you equate for protein and your resistance training is what it is, then there shouldn't be any concerns about time restricted eating. What do you think here based on your research?
Yeah. So I think within a certain intensity of the intervention, it would be kind of personal preference, practical considerations. I think there is a intensity at which the intervention could potentially be inherently detrimental. Um, there are definitely some questions here. So going back just briefly to the acute fasting and when certain metabolic events occur, a big question here is when does, say, protein utilization as an energy substrate increase? Because that's generally something we'd want to avoid if we're trying to promote, as particularly if we're trying to promote a positive, say, muscle protein balance, but even kind of a neutral balance. Early fasting works from 100 plus years ago seemed to indicate that protein utilization didn't increase until after a few days of fasting. There have been more recent trials that seem to indicate that could happen a little closer to 24 hours or slightly after. It's not entirely clear in those periods between, say, a short overnight fast of 8 hours and 24 hours, not entirely clear when this occurs. Our 24-hour fasting study, actually, the primary aim of that was looking at protein breakdown through a urinary marker. And this is why we had to put people on a certain diet. They had to be on a meat-free diet for 3 days because we were looking at 3-methylhistidine, which is released from the muscle. And we wanted to be sure it was coming from their muscles if we saw it in the urine, not the muscles of the animals they were eating. So we didn't see an increase in protein breakdown relative to after an overnight fast or during the relative to the feeding periods, actually, with up to 24 hours of fasting. There are probably more sensitive measures, so it's still something that needs investigation, but this has been an interest of our lab for a few years, kind of wondering about, at what duration of fast are we concerned from a muscle protein balance perspective? Looking at the interventions we've done, so one in particular, the most recent one we conducted here, which was in resistance trained females, they were prescribed 8-hour time restricted eating. The eating window ended up being about 7.5 hours. They were able to exhibit increases in muscle thickness, increases in whole body fat free mass, equivalent to a control group that was eating over 12 or 13 hours a day, when both were consuming 1.6 grams per kilogram of protein on average and approximately at energy balance. So there's no body mass change. Um, just some like so-called recomp, if you want to call it that. So I would feel moderately comfortable saying something up to that level of aggressiveness. So 8 hours with appropriate calories, with appropriate protein would still support increases in muscle size. Now, I still think it's worth considering that same idea that you'd have for, say, true athletes, the idea of missed eating opportunities. So if you're at 8 hours, if you extended to 12 hours, would you be able to get in another meal that you need to get the surplus you want, or to jump up from 1.6, you want to be up at 2 or 2.2 grams per kilogram? That would be kind of a easy example of where it's like, okay, you need to extend this eating window. Like if you can't eat anymore, can't get higher protein, can't get the nutrient density you need in the 8 hours, you may need to extend it. If someone is able to equate everything, I think the differences would probably be pretty minimal between 8 and much longer than 8. So like 8 versus 10 versus 12. But still within the realm of, if you want to be sure, or say in the context of bulk, if you want to be sure you're not leaving a gram of potential muscle you could have gained on the table, I would personally recommend a longer eating window, because in that context, I don't see really an advantage to forcing all your calories into a shorter period of time. Again, in particular, if someone is say like a hard gainer, has a hard time eating the calorie intake they need to gain. But even if that's not true, I just don't see a huge benefit for it. On the cutting or prep side, sort of similarly, I think there's an intensity of intervention where this would be problematic. You're in a, energy deficit such that the increased protein utilization may be a concern anyways. And that's where we see, some of the guys who put out great work in this area recommend even higher protein intakes than you would see if you're at energy balance or in a surplus. So you don't really want to add like another potential catabolic stimulus on top of this, or catabolic to the muscle. If it's catabolic to the fat, that'd be, good. Um, so I still think you could probably get away with 8 hours. I wouldn't go shorter than that. And I would not fault anyone for being skeptical still of 8 hours and saying like, no, we need to do 12 hours. There are also things like pre-sleep protein ingestion is often a strategy people use. Some people have some interesting research in this area, including Mike Ormsby and others. So if that's being targeted as a strategy, that would probably make it difficult to stick to a short eating window without just shifting your calories in a direction that you might not want to, like not eating till mid-afternoon or something like that. So I would say there's quite a few reasons why you wouldn't implement this. If you were going to, I personally wouldn't recommend shortening the eating window beyond 8 hours. And again, the reason why I feel kind of comfortable at that duration is just because of our own data. With that said, only one of our studies was done in a population I view as like very similar to physique athletes. It was largely in individuals who identified as natural bodybuilders. I think they had a BMI of something like 28 and a body fat percentage of 13% on average via DEXA. So they were muscular individuals. This is one conducted in Antonio Paoli's lab over in Italy. It was a 8-week study. They just maintained muscle mass or lean mass over that time and muscle thickness. So in terms of the ability to maintain in a highly trained individual, I think that's there also. But again, the closer someone is to their ceiling, the more you don't probably want the risk of having a suboptimal adaptation due to your dietary program. So that's kind of a long meandering answer, saying that I see some parallels in both kind of the bulking off season side and the prep in season side.
I think that was great context. In regard to the specific study in Paoli's lab with the more advanced trainees, which specific one was that? Was that the 16-8 protocol?
Yeah. So Morrow is the first author on that, Morrow 2016 in Journal of Translational Medicine.
And in that one, wasn't that when the time restricted eating group lost like a substantial amount of weight compared to the other condition, or no?
Yeah, I wouldn't really call it substantial. I have to look up the exact amount. The fat loss was a little over a kilo, which
Okay.
for groups that start out that lean, again, I think they were starting at around 13% body fat on DEXA. That's a decent amount. And if you look at that as a percentage of their fat mass loss, it looks like a really large fat mass loss. They were prescribed calorie intake that was equivalent between the control group and time restricted eating group, but a limitation of all our studies and any study conducted outside of a metabolic ward where you're watching them eat every ounce of food is you can't, even if it doesn't show up on the diet records because they can be noisy, you can't fully eliminate the possibility that these individuals ate less. It's also possible that maybe eating in better alignment with well, actually, that wouldn't really be the case in this one because they were timed together on dinner. So in other studies, you could make maybe a circadian argument for the thermic effect of food being higher when you're eating earlier in the day or something like that. But that wouldn't apply to this particular study. But yes, there was some fat loss in the time restricted eating group in that study.
Got it. Okay, Grant, that is all I have for you today. This has been a phenomenal discussion. I really appreciate your time. I know the listeners are going to get a ton out of this episode. For those who want to learn more about you, go and support you, where can we point them towards?
Yeah, so I do have a personal website, which is just granttinsley.com. I have links to my social media. I have information about my research team, research lab, publications, and so on. I'm probably, I guess, most active on Instagram, and my handle there is Grant_Tinsley_PhD. I'm also on Facebook and Twitter, but probably do more on Instagram. So that's probably the best place to connect.
All of those links will be in the show notes, but that does it for another episode of the Muscle Memoirs podcast. Thank you so much for listening, everyone.